Let's solve this problem. The same problem actually we are going to solve using the most recently used page replacement algorithm. See, so far we have solved least recently used page replacement algorithm, first in first out page replacement algorithm and optimal page replacement algorithm, and we have found out the number of page faults. Now we are going to use a new algorithm called as most recently used page replacement algorithm. Let's see this. Initially, CPU wants to access page number 4. So, since we are using demand paging, page number 4 will not be present in the RAM before that. So, it will lead to one page fault, and then we will place page number 4 over here. Then page number 7 comes. Page number 7 is what accessed by the CPU, and so page number 7 will lead to one more page fault. And next comes page number 6. So, I am going to place it here. Fine. Now comes page number 1, right? Page number 1, and we don't have enough frames. See, as we have our process has been given only 3 frames, right? Our process has been allocated only 3 frames, and so we don't have any free frames. So we might have to go for page replacement. One of the pages has to be replaced with page number 1. Now, which page should we replace? And that is being decided by the page replacement algorithm, which is nothing but most recently used. See, what do they mean by most recently used is the page which has been accessed by the CPU recently. That is what we mean by most recently used. See this, when we are trying to place this page in the RAM, right? Out of these three pages, the page which has been referred recently by the CPU is nothing but page number 6, right? This is the most recently referred page by the CPU. So by this rule, we will replace this page. We replace this page with page number 1, right? Then CPU wants page number 7. Page number 7 is already present in the RAM, so we will not have any page fault. Fine. Now let's see this. And next comes page number 6. Page number 6 is not present in the RAM, right? So we might have to go for page replacement algorithm. Now which page should we replace here? We need to replace the most recently referred page by CPU, right? See, when we are accessing this is the most recently used page, right? Page number 7 is the most recently referred page by CPU, and so page number 7 has to be replaced with page number 6, right? Fine. Then comes page number 1. Page number 1 is already present in the RAM, so there is no page fault. Fine. Then comes page number 2. Page number 2 is not present in the RAM, and we might have to go for page replacement. So which page will we replace here? The most recently used page is nothing but page number 1, right? So this has to be replaced with page number 2. Fine. Then they are asking page number 7. Page number 7 is not present in the RAM, and we need to replace the most recently referred page, which is nothing but page number 2. So page number 2 will be replaced with page number 7. Fine. Then again CPU asks for page number 2. Page number 2 is not present in the RAM. Just now we have swapped out page number 2. So we might have to again swap in page number 2, replacing one of the pages. So the most recently referred page is nothing but page number 7. So page number 7 will be replaced with page number 2. Right? So that's it. We have done all the requests, right? Now how many page faults? 1, 2, 3, 4, 5, 6, 7, 8. So the number of page faults is higher in case if we use most recently used page replacement algorithm for this problem. That is important. Okay? For this problem, most recently used page replacement algorithm is not a good idea. That's what we mean by this. Okay? How many page faults we got? 1, 2, 3, 4, 5, 6, 7, 8. So the number of page faults is nothing but 8. In case if we use most recently used page replacement algorithm. Now consider all these 4 algorithms. Which is the best algorithm? Obviously optimal will always be the best algorithm, right? Always you take any other algorithm apart from optimal, you will see that the number of page faults is either greater than or equal to optimal, right? What do I mean by this is, you take any algorithm, say A, I'm naming the algorithm as A. The number of page faults in this algorithm will be greater than or equal to optimal. Optimal algorithm, in case if you use optimal algorithm. That's what I'm going to, and that's what I'm saying, that optimal is the best algorithm. Whatever algorithm you use, you are not going to get the number of page faults to be less than that of optimal, right? Fine, but there is a problem here. Optimal algorithm, though it gives the least number of page faults, the problem here is it is not practically implementable. We cannot implement this practically. Now the question you might ask is, if we cannot implement it practically, then why are we studying about optimal replacement algorithm? The reason is simple. We are using optimal page replacement algorithm for benchmarking. What do we mean by benchmarking? It is just used to compare the number of page faults. See, let us assume we are using least recently used page replacement algorithm, and we got the number of page faults as 6. Right? Now what we do is, we will also use optimal page replacement algorithm, and then we will find out the number of page faults. Fine, we found out the space 5. Then from this we can come to a conclusion that LRU is closer to optimal, right? Optimal is the best algorithm. Now LRU is almost giving the same, right? It is slight variation. So LRU is a good algorithm. Whereas in case if we consider MRU and optimal, you will see that there is a big difference between both these algorithms, right? So from this we can say that MRU is not closer to optimal. It is not a better algorithm for this problem. Okay, fine.